Welcome to today's lesson on angles related to a circle. When this lesson is complete, you will know how to determine the measure of an inscribed, tangent chord, or chord angles. You will also know how to find the measures of a secant, secant, tangent, and tangent angles. Let's get started. In our first two examples, we are going to deal with a vertex that's sitting right on the circle. So you can see in example 1, that would be vertex B, and in example 2, vertex F. So when we have that situation in the first example, we're going to call that an inscribed angle. I think you've dealt with this before, so you probably already remember how this is going to play out. And we have the measure of the arc at 112. We can see that the information given to us here is 112, so let's go ahead and put that on our diagram, and we'll get 112. And how does angle B compare to the 112? If you'll remember, it's 1/2 of that measure of the arc. So remembering that rule, we'll get the measure of angle B to be 56 degrees. Moving over to example 2, we have a tangent line, which is FE, and we have a chord that I'm going to color in green, DE. Those two make up the angle, DEF, and if you'll notice, the red one is a tangent, the green is a chord, hence this is called a tangent chord angle. How do we figure out the measure of angle E, given the fact that DE is 80 degrees? So what they're saying to you, I'm going to highlight it. I'm going to highlight it in light blue here. This is what we have to find. You'll notice that that particular arc is intercepted by the D and the E. And for that reason, there's a relationship here, and the measure of angle E is going to be, once again, 1/2 the measure of the arc DE. So that would mean that the measure of angle E is going to be 1/2 80 degrees, and so the measure of angle E is 40 degrees. So you'll note that the measure of an inscribed angle or the tangent chord is 1/2 the measure of what we call the intercepting arc. Once again, the intercepting arc is in pale blue. I'll put that in example 1. That's an intercepting arc, and DF is the intercepting arc. All right, in our next example, we are dealing with what's called a chord theorem. And in the chord theorem, here's what's going to happen. We have a chord and another chord, and they have intercepting arcs that I'm going to highlight in pink. If I take the sum of the two pink arcs and cut them in half, that will give me the measure of the vertical angle, or in this case we're calling it angle X. So here's how it looks when we write it out in equation form. The measure of angle X is equal to 1/2 20 plus 15. Go ahead and finish computing. We get 35, and we get 17.5 degrees. In our next example, we're going to go ahead and do the reverse of that. So press the pause key, see if you can figure out how to solve this without me explaining it to you, but I am going to explain it to you. As soon as you press the play key, you'll find out the answer. So this time I'm given an arc and the angle, and I have to find the other arc. So that would mean that 72 is going to be equal to y plus the 21, and of course I have to cut that in half. So if I go ahead and solve this like a regular algebra problem, I'm going to multiply by 2, and then I would get 144 equals y plus 21, y equals 123. That's all there is to it, and that's called the chord theorem. In part C of your notes, we're going to be dealing with angles that have vertices outside the circle. Now there are 3 cases of this, and when we know this, the measure is 1/2 the difference of the intercepting arc. So I'm going to use different colored pencils, red and green. Feel free to grab your own colored pencils. Press that pause key and come on back when you have that, and we're going to continue on with this. In our first example, we have secant, secant. CA and DA are secant lines. The intercepting arcs are CD and BE. Now, having that information, we can go ahead and follow Theorem 88, which states that the measure of angle A will be 1/2 the arc measure of CD minus the arc measure of BE. If we fill in the information, we'll get 100 minus 20, which is 80. 1/2 of 80 equals 40 degrees. In example 2, we have a secant-tangent situation. Secant is line JF, and the tangent line is KF. We're going to go ahead and fill in the information that we know, that JH is valued at 100 degrees, and KH is 60. Now let's go ahead and find their intercepting arcs. Using our colored pencils, we know that JK is one intercepting arc. That's where the lines meet the circle. And the other intercepting arc is KH. We need to subtract the green from the red, but we don't know the red. We can find it though, because we know that JK, the measure of JK, that arc measure is going to be 360 minus 100 plus 60. And when we do that, we'll find out that that equals 200. Now using the formula, the measure of angle F is going to equal 1/2 the red arc, which is 200, minus the green arc, 60. So 1/2 of 140 will give me 70 degrees. Finally, the last example 3, we have, so tangent, tangent would be that PQ and MQ are the tangent lines. My intercepting arcs look like this. I have PM, and this is what's kind of interesting, is the intercepting arc that we're subtracting is actually just the opposite arc. We don't have the red arc value, but we can find it by using 360. 360 minus 100 would give us 260. So now we're ready to find the measure of angle Q. Here are some more examples incorporating the theorems that we learned today. I would like for you to try example 1 on your own. Work it out. As you're working, have that pause key pressed, and when you come back, I will show you how to do this problem and give you the answer. Well, welcome back. Let's see if you got the answer right. We have the intercepting arc of 51 degrees and 31 degrees. So when we take 1/2 of 51 minus 31, we get an answer of 20. Final answer is 10 degrees. How'd you do? Now in example 2, you're going to do the same exact process, only you're given different information, so you might have to set it up a little differently. Go ahead and give this one a try. Press that pause key. Come on back when you're done. Welcome back. Let's see if you got the right answer. In this particular problem, I know that the arc measure is going to be 125 minus Z, and then we're going to cut that in half. So 1/2, 125 minus z. We already know the value of that angle outside the circle, and the value of that is 32. So now we just have to go ahead and do some simple math. Let's get that 1/2 over by multiplying both sides by 2 to get 64. Negative z is going to equal negative 61. Dividing both sides by a negative, final answer is 61 degrees. You'll notice that if our angle is outside, once again, we will use subtraction. If it's inside, we would use addition. All right, so in our last problem, it's extra credit. All you have to do is tell me the value of x and y. I'm going to give you one clue. Here it is. Good luck. Don't forget, no work, no credit. Wrapping up our lesson for today, we learned 3 important points. Inscribed and tangent chord angles are half the arc measure. If we're looking for an angle measure that is inside the circle, then we are going to think addition of those arcs before we cut them in half. And if it is outside the circle, that angle, then we are going to be thinking about subtracting those arc measures before we cut them in half. Well, that concludes your very first video lesson. I hope you enjoyed it. Now tomorrow in class, you'll not hear me lecture. No, you've just done that. You're going to do some practice problems. I can't wait to hear what you have to say about your very first video lesson. We'll see you soon.